Randy Sargent is Senior Systems Scientist with the CREATE Lab. The CREATE Lab is actually part of our Robotics Institute here at CMU. He's also a visiting scientist with Google. He received his bachelor's and master's at MIT, and we're delighted he's here with us today to talk about Earth Timelapse. Randy. And we'll have a little tech transition here. Welcome.
So I'm going to show you something that we call Earth Timelapse. And what we're going to see is a map of the planet that changes over time. And I need to get my display set up properly so you can see what I'm seeing. Hold on a moment. How's that? Now let's take a look at this time-lapse map. I'm going to start off zooming into Las Vegas. And let's start in 1984. Zoom into Las Vegas. You can see the airport here, the strips over here. I'm going to hit play, and let's see how Las Vegas changes over a 32-year period to present day. We're going to kind of keep looping that. As you watch Las Vegas grow, you can see a few different things going on. You can see the suburbs growing, you can see the airport get larger, you can see all of these green areas that we're building out here in the desert, golf courses and whatnot. And at the same time you see all that, if we pan over to the east, you're going to see Lake Mead get smaller. So here's Lake Mead in 1984, and let's see it getting drawn down. And that's both being drawn down due to overuse, but also local drought. Let's take a look at a few other spots. Let's move to China. And I'm going to look for Shanghai here. In the same time that Las Vegas was the fastest growing city in the United States, Shanghai was the fastest growing city in China. In 1984, it was about 7 million people, and it grew to about 25 million people by present day. So now I'm going to hit pause and go back to 84. You can see how compact Shanghai started off. And if we jump straight to 2015, you're going to see that it's expanded well beyond its original bounds. It's connected to kind of all the other cities in the area. It's become a megapolis or a mega city. Let's move to Dubai. Dubai didn't grow nearly as much in population as Las Vegas or Shanghai, but we see increase in other ways. So we see the Palm Islands being built. This requires lots of resources. On the plus side, lots more shoreline. And now let's move to where I grew up. This is we're going to move to Dallas-Fort Worth. Dallas-Fort Worth roughly doubled in population from a bit over 3 million to 7 million during this time from 1984 to present day. If you look closely, you'll see a lot of that growth is to the north. Here's Dallas on the right. If we zoom in all the way, you'll see the farmland turning into city. Because we're talking energy, I'm going to pan a little bit to the west. Now we're a little bit north of Fort Worth. So I panned a little bit too far, sorry. And look really closely at all these white dots that appear. These are all fracking pads. So this is the Bakken shale, not the Bakken shale, this is the Barnett, thank you. Thank you, in the Dallas-Fort Worth area. Now, there's another way we can look at this growth. You've seen maps of lights at night. We decided to do with Google Earth Engine an analysis to show how the lights have changed over the past 25 years. So let's hit this. And what we're looking at is lights at night, color-coded according to what's changing. So here in green, we have areas that haven't changed much at all. So this is Fort Worth on the left, Dallas on the right. In red, we have increasing brightness. And you can see the ring of growth around Dallas-Fort Worth, especially, again, to the north. Zoom out a bit, and we can look at other places. We can see Atlanta also has been growing an awful lot. See Houston, Austin, Phoenix, back to Vegas over here. So that's the United States. You can see also some big red areas, which we'll get back to in a little while. I'm going to zoom out, and let's look at Europe, and let's look at Asia. So here's China. So China's almost all red. So we see lights increasing across the country everywhere. Go back to Shanghai, and you see again the small area of Shanghai to start with, and then lights everywhere afterwards. Compared to Japan, Japan didn't change that much in light output over a 25-year period. But the story of China really is a story about people moving from the farms into the cities growing, people's standards of living going up, people's industrial activity going up, and all of these lights require energy. All of these activities we're talking about require energy. So in large part, what you're seeing color-coded across the planet is energy use. So I apologize. The bar at the bottom actually isn't active right now. This is showing a wrap-up of the last 25 years. So we wrote the software, we're still working on some of the pieces here, but we shouldn't be showing that time bar right now. What we're showing is from around 1990 to present day, that trend. So let's focus on energy. So as we see the energy needs increase, where are we getting that energy from? So if I go back to the beginning here, let's take a look at coal mining to start with. This is the Eagle Downs coal mine in Australia. Most of the coal extracted in Australia is exported to China. What we're seeing is 32 years of growth of that coal mine. If we move a little bit closer to home, we'll see another form of coal mining called mountaintop removal. Here we are in West Virginia. We're going to zoom in about as far as Landsat will take us. And what you're seeing is maybe 6 or 7 mountains here, the tops being blasted off and dumped into the valleys to make access to the coal. I'm going to zoom out. Now we're looking at maybe 100 miles east to west. We're looking at a few dozen mountains. Let's keep zooming out. So in all, we're talking many hundreds of mountains over a fairly large area. I'm going to move to a different satellite now. Let's look at fires. This is, instead of showing 32 years, we're showing 1 year of fires now. And you can see different places on the planet, the fires have different patterns. Let's zoom into Africa, and you're going to see a lot of agricultural fires. You'll see north of the equator and south of the equator 6 months apart. And these fires are lit before the growing season to clear fields, to clear the savanna. In some places, so that the grass that comes back up is a little more tender for grazing animals. In some places, it's to put farms. We can see that same sort of thing in Southeast Asia. Watch the fires move from south to north. as growing season is later, the further north you go. But there are other sorts of fires we see very strongly. Here in northern Africa, in the Middle East, we see these very bright fires. These are oil flaring. This is flaring methane primarily. And if we go take a look at the United States, we'll see a little bit of seasonal burning, but really what jumps out are these three massive oil fields. So these are shale oil fields, and through fracking, we are now producing more oil than Saudi Arabia. And these are the three fields where that happens. So now this is the Bakken in North Dakota. In the Bakken, in most places where we frack, we get primarily methane out of the ground. Here in Pennsylvania, when we frack, we get primarily methane. The methane's put in pipelines. It goes and heats my house. In North Dakota, there aren't as many customers for methane, and it's hard to transport without a pipeline. So here in North Dakota, when we frack, we get about 1/3 methane, 2/3 crude oil, and some of the lighter ends. And this 1/3 of methane is largely flared into the atmosphere. So about 1/3 of the energy that's coming out of the ground goes into the atmosphere in North Dakota. So let's go back to Pennsylvania, and I'm going to switch to a different map. Let's zoom in here. This is a map of oil and gas drilling. Let me hit refresh here. Over time. And the records go back quite a ways. They go back several decades. Let's play just the more recent. So if you start in the late 2000s here, all this part at the end is predominantly hydraulic fracturing. So you see it up in the Northeast, and you see it, of course, in Washington County and the Southwest over here. So that's the sort of time progression that we're seeing with oil and gas drilling here in the state. And I want to end with, on the energy side, let's take a look at the tar sands in Alberta. So here in Alberta, these are largely on pause, in part because the cost of oil has gone down enough that this is no longer economical, but there are also strong political forces against this right now. And one of the reasons is that for the energy taken out of the ground here, about 50% of it is burned into the atmosphere to process the other half. So tar sands are very energy intensive to process. So what are the sort of things that this is causing? So as we know, carbon dioxide is going up in the atmosphere. This is a video from NOAA showing the progression of carbon dioxide since the beginning of the Industrial Revolution. Right now we're going 79 to present day. And I'm going to speed through this. And what you're seeing here, let me go back just a bit here and hit pause. What you're seeing here is that we've reached over 400 parts per million in CO2. If you count the equivalent of methane and other greenhouse gases, we're actually over 450. And we were back around 280 before the Industrial Revolution, so we've almost doubled what we see in the atmosphere. And we know that's making the planet hotter. Let's take a look. This is from Berkeley Earth. We're going to watch the planet heat up over since before the Industrial Revolution here. The colors are set with a baseline around 1950. So we're starting off with blue looking cold, but in reality we're raising all the time since 1850. So if I were to redo this, I would probably make it get red and redder. So you can see up through 1950, now we're kind of at the more even tones. You're seeing that the heating is uneven, right? You'll see like the poles especially start to get hotter. We take a little bit of a pause after 50, and then it really starts to kick in starting in the 1970 or so. You see very strong warming in the polar regions especially. So what are the sort of problems that we see from that? One of the problems that we see is from glaciers retreating. So let's take a look. So we're going to go to Columbia Glacier in Alaska. So here we are in 1984, and watch the front retreat to the north about 20 kilometers in these 32 years. Another thing we're seeing today that's visible on satellite, using a different satellite, we're going to go to coral reef. And this is showing the hospitability of the ocean to coral reef, starting in about 2013. And in the red and dark red areas are places where coral would not be expected to survive long term. And you can see that there's a lot of seasonality. We're seeing heat effects. If we fast forward a bit to 2014 summer, winter, then back to 2015 here in the summer coming up, you'll see a very strong signature of El Nino. But another problem that we're having is that the oceans are becoming more acidic as we get more carbon dioxide in them. So we're really disturbing the ocean food chain in a fairly major way here. We're seeing a very large bleaching event right now with the coral. I'm going to turn off coral, and let's go to Syria. So I'm going to go to the northeast part of Syria, and let's turn back on time-lapse. For 1984. Let's jump to 97, 98, 2000, 2003. This area up here is an area that's irrigated. There's lots of food growing here in 2003. And as many of you know, in 2006, Syria started to see it's the largest drought in its recorded history. So let's move forward a few years to 2006, 2007, 2008. And this area which was green is no longer green. And what we know happened from this is about 1.5 million people left the farms, left those areas, and had to move to the cities. We also know that in 2011, the Syrian civil war started. And there are many people who connect those two events. So as you're thinking about displacement from climate, this may be one of the early large examples of that. I'm going to move to a different data layer. So I want to show solar a little bit bigger here. So I'm going to go back to 1984, and I'm going to turn on the solar photovoltaic overlay here. And we're going to move from 84, watch California, 94, 2000. By 2004, California really starts to light up. And we're seeing many thousands of installs. Now, most of the installs you see on this map are just going to be things on people's roofs, but there's also a fair bit of utility scale as well. Let's zoom out. And if we keep watching as we move forward now, watch the East Coast now. So we go from 2004, here we are in 2009, the East Coast is starting to light up. New Jersey really lights up initially. Massachusetts is close behind. Now we're 2013, 2015. And I'm going to play that through pretty fast from 2000 to the present day. We're seeing quite an acceleration of solar installs in the past few years. We're up to about 1% of all of our power being supplied by solar. China's about the same number as well, but China's growing faster. So China's probably going to pass us in the next year. Let's go to wind. So wind's going to show up in green. By 2001, we see a fair bit installed in Minnesota. I'll switch to a different map here so you can see what the boundaries are. Now as we move forward, by 2008, we see a whole mess of it installing in Texas. And these initially were kicked off by state renewable power standards, portfolio standards, but today they're well in excess of the portfolio standards. So today you see them all over the U.S. We can zoom in and see the patterns of them. So today, wind is giving us about 4% of our electricity, and it's growing quite quickly. So I want to end by asking a question. I want to ask, how many people in this room know where the electricity that you use at home comes from? Almost no one. Has anyone gone through the trouble to select a supplier on the basis of the electricity coming from wind or solar or some other source? Almost no one. Yeah, I'm going to say that. So the lights here right now, so CMU is paying for it, is getting 100% solar and wind to power these lights here. So when you're here, that's the power you're using. Well, I mean, there's an interesting question, right? I mean, I think this is a question that comes up a lot. Like, if you pay for, so at home, I pay for community energy, wind and solar, and that's produced primarily in the central part of the state. The electricity is fungible, so if it goes onto the grid there, and I'm pulling off here, I call that green. You can choose to disagree, but I think that when we're looking at carbon dioxide in the atmosphere, it kind of doesn't matter where it comes from. So I would encourage, will anyone raise their hand to volunteer that when they get home, they'll look into purchasing renewable power? Okay, so I see a few hands, so thank you, and I'll end with that.